Hi everyone. Today we are going to discuss problem number 5 based on homogeneous equations. Let's see. Here you have to given a problem. Discuss the value for k, the system of equations 2x plus 3ky plus 3k plus 4 into z, that is equal to 0. Second equation, x plus k plus 4 bracket complete into y plus 4k plus 2 into z, that is equal to 0. And third equation, x plus 2 in bracket k plus 1y plus 3k plus 4 into z, that is equal to 0. So now this is given system of equation. Now we have to discuss the value for k, guys. We have to discuss the value for k. Means you have to find the value of k and let me predict the what is the solution for given system. Let's see. You observe the all equations, since RHS of all equations are zeros, so that's why this is a completely homogeneous system. That's why it is completely homogeneous system of equations. So for that we have to first write as the matrix form of a system is, what will the matrix form of a system? It can be written as for homogeneous system, that is what a into x, that is equal to z, means this is z is called as null matrix. So therefore we write first coefficient matrix A, then unknown matrix x, then null matrix 0. Let's see. The matrix form of a system can be written as Ax is equal to z. Now we write the coefficient of matrix A. Let's see. How to write the matrix A? It is just you have to write the coefficient of x, y and z. You have to just write coefficient of x, y and z. So in first equation, coefficient of x is 2, then coefficient of y is 3k, that will be 3k, and then that is a 3k plus 4, it will be 3k plus 4. You have to just observe the coefficient. Next, second equation coefficient is 1. Next is what is that here, k plus 4. Next is what is that, 4k plus 2. In third equation, 1 2 into k plus 1, that can be written as a 2k plus 2. And next one is a 3k plus 4. 3k plus 4 is there. So this is a matrix A. Unknown matrix I am writing here x, y and z, because 3 unknowns is there, and therefore this is equal to RHS matrix, that is equal to 0 0 0. Okay, where A is called as a coefficient matrix. This is what coefficient matrix, where I am writing here A is equal to coefficient matrix. For reference, we say the equation number 1, x is called as unknown matrix and z is called as null matrix. We have to first perform on this equation or on this matrix form some row transformation. We have to interchange r1 r2. Let's see, guys, we have to interchange r1 r2. Now we take some transformations of rows is there. So we take here r1 interchange r2, means the operation is performed here r12. Then what will get the system is, what is the matrix A? I am writing once again, that is 1 2 1. Now if we changes the row 1 and row 2, means these are interchanged, so row 1 becomes row 2 and row 2 becomes row 1. Means what is that here, 1, here is a 2, here is a 1, k plus 4, next element of that row is 3k. Next one is how to write, this is 2k plus 2, nothing will be changed in third row, that is 3k plus 2. Now next one is what is that here, 4k plus 2, then 3k plus 4 is there, and then also 3k plus 4. This is a matrix A. What is a matrix X? That is x, y, z. And then what is a matrix 0? That is another matrix. We have to write 0, 0, 0, means that is a z. And this is a x is equal to z, guys. This is a x equal to z, right? Simply you know very well this is a matrix of homogeneous system. Now also we have to interchange this, or we make the sum element, means we make below the leading element are 0, means we perform here r2 minus twice r1 comma r3 minus r1. So how it will be do here? So let's see. Here if we perform this r2 minus twice r1, so below the one element all elements are 0, then nothing will be changed in first row. So that's why this is a k plus 4, and I'm writing here is a 4k plus 2 as it is. Now change in second row, guys. This is what k minus 8. Also change in third row. Third row is what? R3 minus R1, means what is that? Here is remaining only k minus 2. Then 4k plus 2 is element change in second row, that is a minus 5k, and also minus k plus 2 is there. This is a into nothing will be changed in x, y, z, that is as it is, only change in a matrix, means respective change in here only matrix A. So therefore this is what? This is x is equal to z is there. Now clearly you observe this matrix. This is what? 3 by 3 matrix. So here I am considering here m is equal to number of equation is equal to 3, and that is equal to number of unknowns. Means simply it is m is equal to n. So that's why therefore when it has a solution, means if determinant of A is not equal to 3, then system has a trivial solution. So I am writing then system has a trivial solution. That is number one condition we check here. And number second condition we check if determinant of A is equal to here not a 3 is exactly there, determinant of A not equal to 0, then it has a trivial solution. That is which type of solution is there? That is x equal to y equal to z equal to 0. That means trivial solution. And if determinant of A is equal to 0, then system has non-trivial solution. Now let's see, guys, if system is a trivial, then it has a unique solution, means a 0 0 0 solution. And if determinant of A is equal to 0, then system has a non-trivial solution. Now let's see. We have to check the conditions. We have to first find determinant of A. So how to find determinant of A? So let's see, determinant of A is nothing but it is a mod of A. So mod of A can be written as, this is a mod of, you have to write the element in this determinant notation. So 1 0 0, then k plus 4, k minus 8, k plus 4, k minus 8, k minus 2, 4k plus 2, minus 5k, and k plus 2. You observe, guys, what is matrix A, and you have to just find its a determinant. Let's see, this is a matrix A. So in this way you have to write the determinant is what is. Now if you are simplifying this determinant, so what will you get? Simplifying this determinant, so means you have to getting k minus 8 into, that is a k minus k plus 2 plus next element is a 5k into k minus 2, means what is that? Here we have to multiply it, or you have to solve this determinant. So 1 into k minus 8 minus k minus 2, there is a multiplication is there, minus minus there is plus 5k into k minus 2, means if we write that is 1 into first row and first column delete is this, and we have to just here do the operations as into this. So this into this, right? So in this way So this is what my determinant simplification you know very well. So I'm not getting much time in this calculation. So second one is 0 into 0. So that's why only this product will happen is there. Only this product will happen is there. And hence we can write k minus 2 as a common factor in all factor space. So k minus 2 I am writing here common. Now in bracket is remaining minus k plus 8 plus 5k. And therefore you have to write now this in this way, that is a k minus 2 means I'm also write here 4 into k minus 2. After simplifying we have to getting that it is a k plus 2. So determinant of a is not equal to here 0. So therefore determinant of a is not equal to 0. And if this is not equal to 0, then it has a non-trivial solution. Means hence system has a non-trivial solution. Yes, system has a non-trivial solution. So let's see how to find its a non-trivial solution. So let me check system has how many solutions. So here what is that, here k is equal to, we have getting the values of k is equal to, let's see, from determinant, from value of determinant, what is that here, k is equal to, k takes the value, k takes the value, which are the value, that is k minus 2 into k plus 2, means here k takes the value, k is equal to plus 2 and minus 2. You check here, k is equal to plus 2 and minus 2. So for k is equal to plus 2 we check case number 1, and for k is equal to minus 2 we check case number second. Now let me start how to find it has a non-trivial solution, how to find the system has a non-trivial solution. So let's see case number 1. So case number 1 I am writing here case number 1 as when k is equal to 2, when k is equal to 2, the augmented matrix of system is given as the augmented matrix of system is given as. So how to write the augmented matrix of system? You know the matrix A and the matrix 0. So therefore I am writing now in this way, the augmented matrix of system is now in this way. So this is a 1 0 0. If we substituting k is equal to 2, it will becomes 6 minus 6 and 0, then 10 minus 10 and 0, and you know the combination of null matrix as now like in this way, the augmented matrix now like in this way. So we have to perform some operations here. So for we have to convert it into echelon form. Now this matrix is converted into echelon form. So here I am writing reducing the above matrix in echelon form by using row transformations, right? So we have to just make it's echelon form. So by using, so we have to perform here some row transformation, that is a minus 1 divided by 6 into R2, minus 1 divided by 6 into R2. So this will becomes 1 6 10. There is nothing change in first and third row, so therefore 0 0 0 and 0. And now I am writing here, so this is a 1, this is a 10 divided by 6, this will be 10 divided by 6, that is the second row third element. What will happen here? So 10 divided by 3 is there, right? 10 divided by 3. The next element is what is that? 0. So here clearly you observe that this is echelon form. This is echelon form. And if this is echelon form, you know guys very well how to find the rank. So rank of matrix A is equal to rank of matrix AZ. So AZ is what is that? This is augmented matrix. And rank will be number of non-zero rows. You observe here number of non-zero rows. There are 2 rows which are non-zero, therefore this is equal to 2. But rank of matrix A is equal to rank of matrix AZ is equal to some R, and R is equal to 2, and which is a less than number of unknowns, that is n. And n is equal to what is that here? 3. Right? For that, the system has a non-trivial solution. Means when k is equal to 2, we substitute here. When k is equal to 2, we substitute here. So what is that here? System has a which type of solution? System has a non-trivial solution. So therefore system has a non-trivial solution. I am writing non-trivial solution. And if system has a non-trivial solution, we have to take a number of parameter. Therefore number of parameters you have to take, that is equal to n minus r. N minus r means what is that here? 3 minus 2, it will be 1. Means we have to take one parameter is there. We have to take one parameter is there now in this way. So 3 minus 2, it will becomes what is that? 1. So the corresponding system of equation will be, or you have to write now in this way. So therefore we have to assign one parameter for that. We have to assign one parameter. So let's see. From echelon form, or we references, we call this is equation number 1. From echelon form of a matrix, the corresponding system of equation is what is the corresponding system of equation is how to write this? 1 plus means this is y plus 10 divided by 3 into z, and that is equal to 0. We have to take one parameter is there. So how many take the parameter? We have to take one parameter is there. Let's see guys, we have to take one parameter. So put z is equal to, suppose I am writing here t. We have to assign the value for any arbitrary constant. Z is equal to what is that here? T. Clearly you know that x is 0. Clearly you know that x is a 0. So therefore we have to assigning the z is equal to what is that here? T. Or we called the constant is a t. And x is equal to, clearly you know that here is 0. Because of that, the coefficient of x here 0. The coefficient of x here 0. So if z is equal to t, then what will be the value of y? So it is clearly y is equal to minus 10 divided by 3 into z. It is nothing but minus 10 divided by 3 into t. So this will happen. Y is equal to what is that? It is a minus 5 divided by 3 into t. Y is equal to minus 5 divided by 3 into t. So hence for case number 1, hence when k is equal to plus 2, when k is equal to 2, system has x is equal to 0. Next, y is equal to minus 5 divided by 3 into t, and z is equal to t is a solution. So this is for case number 1, when k is equal to, we take 2. Now further we are going to discuss here case number 2. Further we are going to discuss here case number 2. So what is the case number 2 is here? So when k is equal to minus 2, when k is equal to minus 2, the augmented matrix of system becomes, so therefore the augmented matrix becomes, let's see, first of all, you know what is augmented matrix. I am right now once again is there. I am right now once again. The augmented matrix of a system written as, after substituting the value of k. So this is very simple. So 1 0 0, we have to take the augmented matrix 1 0 and 0. Then next value is a k plus 4. I am writing this element as column wise, k minus 8, then k minus 2. Third column is 4k plus 2. Next one is minus 5k. Next one is minus k plus 2, and this is combination of 0 matrix 0 0 0. That is what augmented matrix. This is also denoted as augmented matrix AB. This is also denoted as augmented matrix AB, or sometimes matrix B is a 0. That's why this is a standard notation is there. AZ, the augmented matrix, is given now in this way. Now for k is equal to minus 2, the augmented matrix becomes, so therefore augmented matrix becomes, if we substituting the value of k is a minus 2, so that we will get augmented matrix now in this way. So this is a 10 0, means I am writing here 1 0 0, column wise element 1 0 0. Next is 2 minus 10 4, 2 minus 10 4. Next is minus 6 10 4, and next is all are zeros, right? So this is augmented matrix. Now your next target is you should reducing to echelon form of a matrix, echelon form of a matrix as, reducing to echelon form of a matrix as by using, or I am writing reducing the echelon form of a matrix by row transformation, matrix by row transformation. Means we have to perform here some row transformation, and then it will get in echelon form. So now we do here minus 1 by 10 R2, we do here minus, or we have to perform minus 1 by 10 into R2, and you have to also change in row R1 as, it is a minus 4 guys, that is a minus 4, that is a minus 1 by 4 into R3. So change in R2 and R3, change in R2 and R3. So what will get here, augmented matrix it will becomes, that is 1 2 minus 6 row wise element, 1 2 minus 6, here is a 0, 1 1 minus 1, means I am writing here 0 1 minus 1. Next one is 0 1 minus 1, and 0 and 0 is here. Okay, after making this transformation, we have to getting this. Now simply here two rows are same, so we have to change in R3. So R3 minus R2, it becomes augmented matrix as, so this is equal to, this is 1 2 minus 6, there is a 0 0 1 minus 1, nothing change in first two rows, but here is a 0 0 0 and 0. Now guys, you have to observe here what is the rank of matrix A, means rank of this matrix A totally, and rank of augmented matrix AZ, that is equal to here 2, because of that 2 is a number of non-zero rows, non-zero rows, that is nothing but it is a rank. And also rank of a matrix A is equal to rank of a matrix AZ is equal to 2, but it is a less than number of unknowns, that is equal to 3. It is a less than number of unknown, that is equal to 3. Hence I am writing, hence system possesses, system has non-trivial solution, means infinite solution, infinite solution, that is it has non-trivial solution. So how to solve the non-trivial solution of the system? So therefore, for references we call this is equation number 2, and from equation number 2 we have to write the corresponding equation. So let's see. The corresponding echelon form I am writing here, or I am writing the number of parameters we have to take. How much number of? The number of parameter first. Parameters first. So this is equal to n minus r. You know guys what is n? N is 3 and r is 2. So therefore one parameter we have to allowed is there. And from equation 2, that is from echelon form. Equation 2 is nothing but echelon form. The corresponding system of equation can be written as the corresponding system of equation is, what is that here? So simply I am writing here x minus, because of that here element of y is absent, therefore I am writing here x minus 4z and y minus 4z. So I am writing x minus 4z, that is equal to 0, and y minus z, that is equal to 0, and y minus z, that is equal to 0. So assigning the variable z in any arbitrary value t. So I am writing assigning the variable z any arbitrary value t. We have to assigning this. So we are to getting that x is equal to, what is that, 4t, and simply y is equal to here t. And but you have to already clearly you write here z is equal to t. So that's why therefore x equal to 4t, y is equal to z, y is equal to z, it is nothing but y is equal to also t. Y is equal to z, it is nothing but y is equal to also t. So y is equal to t and z is equal to t. So these are solution where I am writing where t is called parameter. So I am taking only one parameter, because of that you have to allow only one parameter is there, and hence the system has infinite solution, has x is equal to 4t, y is equal to t, and z is equal to t, is infinite solution. That is it has non-trivial solution. So in this way you have to find, or we discuss the value of k, and we discuss consistency, and we discuss the solution or what type of solution. Means simply here I am writing again, for k is equal to 2, system has a solution. Means for k is equal to 2, x is equal to, what is that here, 40. Means in the last few minutes we solve this for k is equal to 2, which are the values for x, y, z. So for k is equal to 2, x is equal to, what is that here, 0, y is equal to, what is that here, for k is equal to 2 we write here x equal to 0, y equal to minus 5 divided by 3 into t, and z is equal to t, and number second I am writing here for number second, for k is equal to minus 2, x gets the values, x takes 4t, y take t, and z take t. So this is a solution. So hence I am writing this is solution of given system of equations, guys. System of equation. I hope you understanding this concept very well and enjoy the example. Understood, guys, this example? Thank you.